Imagine this. The Earth moves just 5 centimeters closer to the Sun. Yes, just 5 centimeters, less than the width of your hand. At first, it sounds completely meaningless, doesn't it? 5 centimeters in the vastness of space? That's nothing. But here's the real question. In a universe built on delicate balance, could something that small matter? Let's explore it together. First, we need to understand something important. The average distance between the Earth and the Sun is about 150 million kilometers. Compared to that, 5 centimeters is essentially zero. So, scientifically speaking, if Earth moved 5 centimeters closer to the Sun today, nothing would happen. No change in temperature, no shift in seasons, no visible difference at all. Life would continue exactly the same. But that's not where this becomes interesting, because this isn't really a question about 5 centimeters. It's a question about balance and how fragile that balance might be. Now imagine something different. What if this 5 centimeter shift wasn't just a one-time event? What if it was the beginning of something? A tiny break in a perfectly tuned system. Earth orbits the Sun in an incredibly precise balance. Gravity pulls it inward, velocity keeps it moving forward, and together they create a stable orbit. But if that balance is disturbed, even slightly, over time, the effects could grow. Picture this. The sky looks the same. The oceans move as they always have. Nothing feels different. But somewhere, deep in the calculations, scientists begin to notice something strange. The Earth's position is just a little off, not by meters, not by kilometers, but by centimeters. Years pass. The change is still invisible to the human eye, but instruments grow more precise. And slowly, a pattern begins to emerge. The Earth is drifting. At first, it's harmless, a fraction closer to the Sun, the kind of change no one would ever feel. But over decades, that tiny shift begins to accumulate. Now imagine looking up at the sky. The Sun appears almost identical, but ever so slightly larger. Not enough for people to notice consciously, but enough for instruments to detect. Centuries pass, temperatures rise, just a little, half a degree, maybe 1 degree, the kind of change people argue about, the kind of change that could be dismissed. Polar ice begins to melt, slowly, oceans rise, gradually, seasons shift, summers stretch longer, winters grow shorter. Humanity debates. Is this natural? Is it cyclical? Or is something deeper happening? Now move forward further, thousands of years into the future. The shift is no longer subtle. The Sun dominates the sky a little more. The heat feels heavier. The atmosphere changes. The equator becomes difficult to inhabit. Deserts expand. Forests shrink. Oceans begin to evaporate in certain regions. Cloud patterns shift. Storms become more intense. Now imagine standing on the surface of this future Earth. You look toward the horizon. The sky is no longer the same blue. It has a faint orange tint. The air feels dense, heavy. The sunlight is sharper, more aggressive. And the Sun, it looks closer, not dramatically, but undeniably. But here's the truth. None of this happens because of 5 centimeters alone. It happens because of what that 5 centimeters represents. A shift, a disruption, the beginning of imbalance. Because in reality, our planet exists within a very narrow range of conditions. A slightly different orbit, a slightly different tilt, a slightly different distance, and life as we know it might not exist at all. Now return to the present. In the real world, if Earth moved 5 centimeters closer to the Sun today, nothing would change. You wouldn't feel it. You wouldn't see it. It wouldn't affect your life in any measurable way. But this thought experiment reveals something deeper. Our world is not just random. It exists because of an incredibly precise balance. And that leads to a bigger question. If Earth were just a little closer or a little farther, would we even be here? If life depends on such precise conditions, how many other planets in the universe are balanced just right? Somewhere out there could be a world almost identical to ours, but slightly closer to its star, too hot for life to begin. Or another world, slightly farther away, too cold, frozen, silent. And maybe, just maybe, there are worlds balanced perfectly, just like ours, filled with life, looking up at their own sky, asking the same questions. So, in the end, 5 centimeters may seem insignificant, but it reminds us of something powerful. Sometimes, it's not the size of a change that matters, it's the balance it affects. Now ask yourself this: if Earth was slow,